Part 2 of the video. Activity 2.3, solving literal equations for specific variables. Convert each literal equation to solve for the given variable. Think inside the box as manufacturing new boxes for you pack 'em, we ship 'em. You pack 'em, we ship 'em told think inside the box that the boxes must have a specific volume and area of the base. However, you pack 'em and we ship 'em did not specify the height for the boxes. Write a literal equation to calculate the volume of a box, then convert the volume formula to solve for height. So the volume formula is length times width times height. Then we want to solve for the height. So this we need to divide by length and width. So the height is the volume divided by length and width. Part B. You pack 'em, we ship 'em specified the volume of the box must be 45 cubic inches and the area of the base must be 75 inches squared. Use your formula to determine the height of the new box. So volume equals length times width times height. It says that the volume needs to be 450 cubic inches and the area of the base, which is length times width, needs to be 75 inches squared. So I need to divide both sides by 75 and the height is 6. Or I could have used my formula and done volume divided by length times width, which would be 450 divided by 75, which again gives me the height of 6 inches. Number 2, the volume of an ice cream cone is the measure of how much ice cream fits inside the cone. An ice cream cone company wants to make an ice cream cone with a greater height that still holds the same amount of ice cream. Write an equation to calculate the volume of a cone, then convert the equation to solve for the height. So the volume for the cone over here is given to us. Volume equals pi r squared times height divided by 3. Or you can think about it as 1/3 of pi r squared times your height gives you the volume of a cone. Then we need to solve for the height. To get rid of that fraction, we can multiply everything by 3. 3 times the volume equals pi r squared times the height. And again, we're trying to solve for the height. Divide everything by pi r squared. So the height is 3 times the volume divided by pi r squared. For part B, explain your equation determines a linear measurement when the original equation determined a cubic measurement. So the original equation in volume is cubic inches, cubic yards. Volume is measured with cubes. When here we changed it and we said the height is 3 times the volume divided by pi r squared. And height is measured in a linear measurement like inches, feet, yards. So since we have a volume that's cubic and radius, which is linear, squared times itself, the area of the base of the cone is in square units, so it's kind of like if you have x to the third power divided by x squared, you would subtract your exponents and you would get x to the first power, and it becomes linear. Number 3. The formula for the area of a trapezoid is A equals 1/2 base, 1/2 height times the sum of the bases, where h is the height and b are the bases. Convert the area formula to solve for the height. So area equals 1/2 times the height times the sum of the bases. And what we want to do is we want to solve for the height. I want to get rid of that fraction, so I want to multiply everything by the denominator. So that gives me 2a, and basically that cancels out to leave me with the height and the sum of the bases. Again, our goal is to get the h by itself, so I'm going to divide by the sum of the bases. So h equals 2 times the area divided by base 1 plus base 2. Part B, it says, use your formula to determine the height of a trapezoid with an area of 24 cubic centimeters and a base of 9 centimeters and 7 centimeters. So we're going to take our formula and plug in the area, which is 24. This is 3b. And then we're going to divide by the bases, which is 9 plus 7. So 2 times 24 is 48. 9 plus 7 is 16. And 48 divided by 16 gives us 6. So the height no, 3. So that gives us 3 centimeters for the height of the trapezoid. Number 4, for the given literal equation z equals a divided by b plus c over d, solve for each variable given, justify your solution. So for 4, we want to solve for a. So if I want to solve for a, I want to clear out the fractions. So the common denominator would be BD. So here I would have Z times BD. And here the B's would cancel out and leave me with a D, so it would be A times D. But in this situation, the D's cancel out and it leaves me with BC. So remember, our goal is we're trying to solve for A. So I'm going to subtract BC from both sides. So I have ZBD minus BC equals AD. Then I'm going to divide everything by D. So if you notice up here, I have a B and a B that I can factor out, which would leave me CD minus C all over D, which equals A. Another way that you can think about it is if I keep it like this, these cancel out and it leaves me ZB minus BC over D equals A. So A would equal ZB minus BC over D. And then if I was going to solve for D up here, I would say Z equals A over B plus CD. And my goal is to solve for D. I would still multiply by the common denominator, which is B and D. So that gives me ZBD equals, my B's cancel out, so that'll be AD. Here my D's cancel out, and that would give me BC. So remember what you're solving for. We're trying to solve for D. So we're going to subtract BC. So ZBD minus BC equals AD. Divide by A, divide by A, divide by A. So here the A's don't cancel out. So we could think of it as a different, where you've got your B's can factor out to give you C, D minus C all over A. Talk the talk. This ought to be duck soup. The formula for the volume of a cylinder is V equals 2 pi r, where V is the volume, r is the length of the radius of the base, and h is the height. Convert the formula to solve for the height. So volume equals 2 pi r times height, and we're going to solve for the height, so we can just divide everything by 2 pi r. So height equals the volume divided by 2 pi r. Number 2, the volume of a can of soup is 37.68 cubic inches, and the length of the radius of the base is 1.5 inches. Use the formula to determine the height. So if we use that formula right there, the height is your volume, which is 37.68, divided by 2 times pi, 3.14, and honestly, I would just use your pi button. And your radius, which is 1.5, and your height will give you 4 inches. Number 3, the formula for surface area of a cylinder is given, where SA is the surface area, R is the length of the radius, and H is the height. Convert the formula to solve for the height. So first I'm going to subtract 2 pi r squared from both sides. So the surface area minus 2 pi r squared equals 2 pi r times h. And my goal is to solve for h. So I'm going to divide by 2 pi r. So h equals the surface area divided by 2 pi r minus the 2's cancel out, the pi's cancel out, and that leaves me with 1r. We could also say that height equals the surface area minus 2 pi r squared, all divided by 2 pi r. That's just another way of writing it. Number 4, the surface area of a can of soup is 51.81 square inches, and the length of the radius is 1.5 inches. Use your formula to determine the height. Alright, so the height equals the surface area, which is 51.81, minus 2 times the radius squared, and my radius is 1.5 squared, 2 pi r, which is also 1.5. Plug all that in, and you should get 4 inches again.